Hey guys, welcome back to Mr. Grand's Garage. This one we're talking about sector area, which is the area of part of a circle, not necessarily the entire thing. If you watched my video on arc length, this is basically the same thing, the same idea. We want to try to figure out how much of the circle, what fraction of the circle is in that sector, and then multiply that fraction by the area in this case instead of the circumference. So with this one, we're basing everything off of the area of a circle, which the formula is pi r squared. Hopefully we can remember that one. It's kind of an important one. So again, first we're talking degrees, right? So we got two versions, degrees and radians. We're going to tackle degrees first. We're going to change things up and make the radius 2 this time. So 360 degrees for my sector. Well, that's the whole circle, so we're going to go pi times 2 squared, which is about 12.57. Then a half circle, we still have a radius of 2. That's 180 degrees. Kind of makes a Pokemon ball. And so we're going to do 1/2 times the area, which is about 6.28. And then if we do 90 degrees again, so radius 2, 90 degrees for the sector. And there's the rest of our circle that we're missing out on. 1/4 pi times the radius squared for 1/4 of a circle, and that turns out to be pi, so about 3.14. Now again, I want to think about this in, how much of the circle do I have? Do I have a full circle, a half circle if it's 180, a quarter of a circle if it's 90? And then we've got our old friend from last time. Oops, that's not 201. That's 201. 201 degrees. Ooh, I can't write. And that's the missing chunk. Alright? So again, just like last time, if I do 360 over 360, because there's 360 degrees in a circle, that's 1. This times 1 is what it is, 12.57. For 180, if I do 180 over 360, that reduces to 1/2. Well, that's why I have a 1/2 in front of there. 90 over 360 reduces to 1/4. That's why we're multiplying it by 1/4. So same thing here. 201 over 360 times pi times the radius squared. And it turns out that is about 7.02 for the area there. So our formula, it's pretty much the same as the last one for sector area, or for arc length, excuse me. If we've got our radius, we'll say our sector is that big, and it is theta degrees, that area is going to be theta over 360 times pi r squared. Like that. Now, again, this is for degrees only. Radians, it's still pretty much the same thing, it's just a different unit, so you need to do it a little bit differently. Now with these, I'm not going to erase everything like I did last time. Make this a little bit shorter and just take out kind of the stuff that's going to change. Ooh, bad marker. Okay, so if we change this into radians now, a full circle is now 2 pi radians. It's still pi r squared. Our half circle is pi radians, still 1/2 of a circle, so it's still 1/2. And this one is going to be pi over 2 radians for the quarter circle, and it's still a quarter of a circle, so it's 1/4 times the area. Let's take a look again at 31 pi over 45 radians, but now with a radius of 2. Like that. I'm going to come back to here and see if I can figure out the pattern from this, right? Now instead of going 2 pi to 2 pi like I did with sector area, now it's going 2 pi to just pi. This one is going from pi to 1/2 pi, or pi over 2. This one is going from pi over 2 to 1/4 pi, or pi over 4. So it seems like what is happening is I'm taking whatever my radians are, dividing it by 2, or multiplying it by 1/2, and then multiplying it by the radius. Let's see if that actually holds true for this one. So again, 31 pi over 45. If we get that in terms of, you know, the fraction of the entire circle, I have to divide it by 2 pi. With degrees, I divided by 360. Here I can do the same thing with 2 pi. So I'll sneak a 2 pi down here in the bottom of the fraction, just like before. That's the same as dividing by 2 pi. And now I'm multiplying by pi r squared. Let's see what happens. Well, 1 pi cancels out, but that 2 doesn't cancel out this time. That 2 is left in there. So really, this ends up being 31 pi over 45 times 1/2, because of that 2 in the bottom, times the radius squared. And it turns out that that is about 4.33. So here's what's happening. When I'm taking a sector area, so there's my radius, it is theta radians, my formula becomes this: 1/2 theta times the radius squared. I should throw an A in there, because I get an A for how awesome the video was. No, because it's area. So again, you know, looking back at what happened here, 2 pi became pi, pi became pi over 2 in the formula, pi over 2 became pi over 4 in the formula, or 1/4 pi. It's whatever the radians are divided by 2 times the radius squared. You could also think of it as what is the whole area, and then just divide the radians by 2 pi and make that into a fraction. And it gets a little messier. This one, if you're going to rely on a formula for one of these and not just to be able to mentally reason towards it, it would probably be this one, just because radians and then dividing with radians isn't always the most fun because it's already fractions. And so yeah.